Hello everyone. Today we are going to see about bedside monitors. These bedside monitors are playing a main role in intensive care and cardiac care units. In this care units, these monitors used to measure the vital parameters when the patients are in the emergency conditions. The parameters like SpO2, heart rate, respiratory rate, NIBP measurements and perfusion index, everything will be measured in the monitors. Then this informations are sent to the central monitors, the nurse station. Along with this, these are the equipments will be used in the ICU, that is ventilators, CPAP, BiPAP, infusion pumps, syringe pumps, blood warmers, and defibrillator units are used. This patient monitoring play a vital role in providing a organization and the displaying of all the informations, and also it correlate the patient problems with a multi-parameter monitor, and also it set data set alarms which used to indicate the abnormal conditions of the patients. It also provide the automated data for therapy planning, and it also ensures the better care and reduce the staff required for handling ICU patients. And this is the one of the bedside monitors. It displays the basic vital parameters. Mostly these bedside monitors are available as a non-fade display of ECG waveform and heart rate. And most of the instruments have a pulse, pressure and temperature, respiratory rate monitoring facilities. Depending upon the manufacturer, the parameters will be included. And this is one of a type of recently used bedside monitor along with the cloud storage. The doctors can see the patient's data from their tab anywhere. It is a block diagram of a recently used bedside monitors. It has a microcontroller that controls the sensor data from blood pressures and pulse rate sensor and temperature sensor, and it is being sent to a router via Wi-Fi ESP module, and it is stored in a cloud depending upon the patient ID. Then by using a protocol, the doctor can uh, access using an Android app. From the doctor's side, it is very useful for 24 hours monitoring of a patients. Mostly currently in market, this type of cloud-based patient monitors are available. Uh, this traditional monitoring devices, they can capable of processing a signal, and hardwares are mostly used for a displaying section, and they are very touch sensitive character displays. And in typical microprocessor based bedside monitors, has a basic units like a preamplifier section and logic boards and a display part. In this, preamplifiers are used to provide a better CMRR ratio compared to other amplifiers. It is mostly used for the low frequency signal analysis section. And this is the block diagram of a bedside monitor. This has a three units as discussed earlier. The pre-amplifier section has the individual blocks for isolating the uh, circuit. It has a ECG and temperature and pulse. The ECG will be provide that heart rate in from the ECG electrodes. We can detect the heart rate by using an R wave detector. The temperature sensed from the patients are also taken as an input. and also the pulse signals. And the next section, that is the logical circuit section. It has a multiplexer. It will give all this input data into A to D converter. The converter give their output to the central processing unit that will store the data, and that will retrieve the threshold ranges from the memory. Then it give us an alarm output and also speaker output. It also displays it in a display unit using an CRT display. The inputs are sent to the CRT module. It display the using a CRT tube, that is a cathode ray tube, which use the principle of X and Y deflection plates. From the display part, the parameters are displayed in the monitors. Mostly, the ECG waveform panel has a facility like lead-off detection, phasor detection, that it has the facial detection unit, and also quick recovery circuit for overloading of signals. And mostly these various amplified signals are sent to this logical board, and also these units are used to uh, control the false alarms and other precautionary actions. The alarm settings are based on the uh, different parameters, and also it also has a defibrillator synchronization module, which uh, which is communicated with the CPU system. uh, the alarm signals are initiated under its control. Mostly the memory capacity about of ROM is 5K bytes, and RAM is about 3.25 kilobytes, uh, with a sample size of 256 for ECG, with a delay of 8 seconds are used for while recording the ECG waveform. Mostly the softwares, everything under memory storage is easily accessible. The microprocessors in the bedside monitors provide the basic signal processing task, and it also have a smart algorithms for artifact removal purpose. If there is any patient movement or any lead offs will be detected. If there is any detected, it is removed by using that algorithms. They are also have the ST segment elevation in the ECG, and that is also considered as a arrhythmia in this arrhythmia monitoring unit. The patient monitor is also known as a vital sign monitor. This is a system block diagram of a bedside monitor. It has a power supply for every unit. That is a central microprocessor unit with a keyboard controlled processor, and it has a multiplexer and the temperature sensors and pulse oximetry transducers. And in the non-invasive blood pressure measurement, it has a cuff and pressure transducer. And for ECG from the electrodes from the patients, it has a lead set that is also connected to the main processor board. And this display boards also connected to the main processor board. These are the basic blocks in the bedside monitors. The whole system under the processor 80C32, which is a 16 megahertz processor. The processor boards are each parameters are displayed. It is the example of the vital sign monitor available in the market. It is an older